Good morning, everyone. I'm Bill Salas with Applied Geosolutions. And yesterday we had some great insight into some remote sensing activities that are being done in situ on the field with the forward sensor box, with the GoPro, and looking at plant architecture and structure. I'm going to change the scale at which we're looking at remote sensing and talk about satellite-based remote sensing. So if we go to the next slide, a little context in terms of what it is we're doing at Applied Geosolutions in Dagan, and we're really trying to utilize technologies to help build the business case for a cover crop economy, primarily through ecosystem service markets. And we address these issues at two very different scales. One is satellite-based remote sensing that can provide us detailed information at the field scale, but also synoptically over large areas, and that's with our platform called the Operational Tillage Information System that tracks practices of regenerative ag. So information on crop rotations, tillage type, currently just cover crop presence or absence, and then some annual metrics having to do with sort of the tenets of soil health, meaning days of green cover, days of senescent cover. We then use that information to drive a soil biogeochemical model called DNDC. That is a model that really focuses on how different microbial communities respond to the soil environment and how conservation practices influence the soil environment, influence soil temperature, soil moisture dynamics, substrate availability, nutrient dynamics. And the outcome of the DNDC model are estimates of ecosystem services. So these tools are being used by several new ecosystem service markets that are being developed in the US, principally the Ecosystem Service Market Consortium, which represents about 55 odd stakeholders in US agriculture. If we go to the next slide, Brian. So today I'm going to talk about sort of three things related to the PSA activities. One is our efforts to improve Optis, so move beyond just mapping cover crop presence or absence, but characterizing the cover crop performance. The second is, with some NASA funding, we've been working on using synthetic aperture radar, or SAR, to map soil moisture and soil moisture variability and dynamics. So potentially it could be an interesting tool to begin to ask some questions at scale about how cover crops influence spring soil moisture, for example. So I'll talk a little bit about our work there. And then lastly, a short update on what we're doing to try to improve the DNDC model itself for modeling cover crop impacts on soil nutrient dynamics and soil carbon stock changes. So go to the next slide. As sort of the theme that Stephen and others have made for the PSA project is we're trying to leverage what the PSA network's doing with other funding opportunities. And so we were fortunate this past year to get additional funding from US Department of Agriculture under their SBIR program to work on improvements to the Optis platform. As part of that effort, we set up a CRADA with Stephen's team at ARS to really focus on, what can we do at an operational scale in terms of monitoring cover crops? How far can we go down the line in terms of mapping cover crop types at scale, mapping performance in biomass, because we realize if we're able to do that, we'll be able to quantify the outcomes of cover crop better at scale to support ecosystem markets. So that work is going to build off of the current Optis platform. I think Rod and Rob mentioned Optis earlier, and I'll get into a little bit more details on Optis with the next slide. Brian, thank you. So again, it's the Operational Tillage Information System, but it really is tracking the sort of the tenets of soil health and regenerative ag. We actually, with the platform, we directly map field boundaries based on management history, because we've done regional modeling using, say, field boundaries from FSA, but they're historic field boundaries, and we've seen many cases where within field management is quite different. So if you're trying to model the impact of that management, you need to segment out those different areas. So Optis does that automatically. We link in with USDA data sets to look at crop rotations and histories. We map tillage practices by directly mapping residue fraction. So we track residue fraction on the field through time. When we see the commodity crop emerge, we then characterize the tillage system based on the residue fraction. So if you look at that lower right panel, you see residue fraction in late 2000 or early 2018 spring, right before crop emergence, and you'll see significant difference between conventional till, which has very low residue fraction, and no-till sites. So that's how we're able to map tillage systems. As I mentioned, cover crop and the other products related to days of green cover and senescent cover, which protect the soil from runoff. We've applied this platform across the Corn Belt from 2005 through 2018. We're expanding it to include all of the Western and Northern Great Plains and extending the Corn Belt data to 2021. Well, the 2020 results publicly available with CTIC website, probably in about 3 or 4 months. The overall accuracy, it's an operational system, so it's not perfect. We're looking at about 90% accuracy on the cover crop mapping. The types of errors that we run into is the field scientists will say, well, that was cover cropped, but there was poor emergence. And so the satellites are not going to actually see that poor emergence. So we have a lot of errors of omission. But all in all, it seems to be working pretty well with a 90% accuracy. If we go to the next slide, one of the key issues, and I think Dean is going to talk a little bit about his work, is cover crop mapping has been demonstrated, but there's an issue with saturation at high biomass levels. And so we're trying to see how we can improve the estimate of biomass at high biomass levels. We're doing that initially with an approach that's a remote sensing based approach that links growing degree days with Canopy architecture. It's called the Canopy Structural Dynamics Model. And that work is then going to be linked directly to drive and constrain the DNC model estimates of biomass dynamics. The preliminary results on the left, we applied this at the different sites at BARC, are promising. It's not perfect. We see a couple sites where we have pretty significant divergence, but we feel that it's worth pursuing and we'll continue to do so. If we go to the next slide, the soil moisture piece I think is pretty exciting. So this approach uses 2 different types of satellite platforms. One is a passive microwave radiometer called SMAP, was designed specifically to estimate soil moisture, but it's fairly coarse. The products are 5 to 9 kilometers, so it's pretty aggregate estimates of soil moisture. We're using that with active radar to then downscale the SMAP soil moisture estimates using the influence of radar backscatter, which is very sensitive to soil dielectric constant, which is driven by the moisture content itself. One of the issues we deal with here is the confluence of, as the canopy of the cover crop or crop residues or commodity crop grows, we're unable to see as much of the soil signal as that canopy grows. So we use an approach to actually invert the crop biomass using a multiple scattering model that uses cross-pole data to estimate structure of the vegetation during the overpass to remove that influence from the soil moisture signal. And I should note that this approach that links SMAP with SAR is really designed for more agriculturally dominated landscapes compared to, say, maybe the Beltsville area because of the coarse resolution of SMAP. But we've done some initial demonstration for some of the sites at Beltsville. And if we go to the next slide, we'll see these are field level estimates on the left of volumetric soil moisture content using our SAR-based approach, which is basically at subfield scale. These are 15-meter pixels where we're estimating soil moisture and soil moisture dynamics compared to the more aggregate SMAP data. And it seems to track fairly well. The scatter plot on the right, again, is comparing our higher resolution soil moisture data with the SMAP data. So I think this is promising. I wouldn't say it's close to being ready for prime time in the sense that I think it's much better at looking at within field variability than absolute volumetric soil moisture content. If we go to the next couple of slides, it will give you a sense of the spatial resolution and temporal resolution of this approach. So So here we just have overpass dates from the Sentinel-1 SAR from the European Space Agency and field estimates of soil moisture. The darker the blue color, the higher the volumetric soil moisture. And you can see seasonality changes over time. And if we go to the next slide, we can maybe drill down a little bit more into one particular field to look at within field variability. So I think the within field variability is something that this kind of approach will really be useful for. We're actually working with soil scientists that are developing soil carbon sampling strategies to understand how to stratify a field for efficient soil sampling. And I think this kind of relative soil moisture information will be really useful for helping inform that process. Yesterday, there were several discussions about the soil moisture network work. I think at this point, we're finalizing the methodology that we think will be applicable and look forward to collaborating with the ground phase data collection groups to try to test and demonstrate this approach over the different sites. It's really designed to be globally applicable. So again, it's focusing on the operational side of remote sensing rather than trying to overfit a model for one particular area. We're really trying to focus on a physical scattering model that's more generalizable over large landscapes to extend the utility of this kind of information for cover crop research and also to support ecosystem markets over time. If we go to the next slide, Brian, and I apologize, I have the wrong title on this slide, but our work on the DNC model has focused on building a broad library of DNC crop calibration coefficients for various cover crop varieties and systems. So to do that, we've built a what we call Calvin, which is a calibration and validation platform that's designed to take a research model like DNC, but calibrate it operationally over large landscapes using hundreds to thousands of data inputs. And it relies on genetic algorithms to do that calibration process. Again, the line of sight of that approach is really for ecosystem markets, which are applied at scale as opposed to calibrating for an individual field or two. The field data that we're really focusing on for calibrating and validating DNC for cover crop work is in-season biomass dynamics and nitrogen uptake. One can imagine the influence of cover cropping on, for example, spring nitrous oxide pulses is really influenced by nitrogen uptake during the growing season. In addition, we need to have a good understanding of total biomass and carbon and nitrogen in that biomass. So following termination, rates of decomposition, rates of nitrogen mineralization will influence nutrient availability for the subsequent commodity crop, but also greenhouse gas emissions and soil carbon dynamics. So we collected data from about 42 studies. So have a pretty good database to do that cover crop calibration, not only the cover crop type, but information on biomass dynamics, carbon content, and nitrogen uptake, which will be useful for the calibration. We're focusing right now on rye, winter wheat, pea, clover, vetch, triticale, lentil, and wheatgrass systems. And so at this point, we've been sort of like the soil moisture work, building the methodology. And now that we have the methodology for DNC, we look forward to collaborating on with the field teams here on looking at how DNC captures nitrogen mineralization rates, doing some testing of the model with the decomp bags and other field data sets. And we welcome the opportunity to work with the broader team if there's interest in the team using DNC for their research for this kind of work, because it's we're trying to support the network as we move forward. So with that was a quick run through on what we're doing, and I don't know if we have time for questions, but thank you for your time.
Thanks. That's great, Bill. I think we've got a few minutes for questions. We've got like about 2 or 3 minutes before we need to jump into the next session, although the next one is tightly linked to your talks. Is there questions for Bill?
Oh, I have one. This is Dennis Timlin. Have you guys tried looking at the yield monitor data from out there related to the water contents to see if there are like relationships with average values and anything like that? I know they've been they do collect them on bark.
We have not. We have not. You mean in terms of looking at the relationships between the relative variability on surface soil moisture content and the yield variability?
Right. You can actually, what you can find is, are those water contents related to sections of the field that have consistently high yields and other sections that have consistently low yields?
Yeah, that's one of the sort of the working hypotheses on using these data, both for sort of stratifying for soil sampling to highlight the areas that are persistently wet and persistently dry. I should note that this SAR analysis is with a C-band radar, which is a short wavelength radar. So we're not getting rooting zone soil moisture, we're just getting surface. There's another platform that's an L-band radar, which will penetrate down several centimeters into the soils. That'll probably give us a better understanding of those kind of soil moisture dynamics. But unfortunately, we don't get the data as frequently. There is a new platform that will be launched about 14 months from now called NISAR, which is the NASA ISRO SAR, which will have an L-band and will have more frequent measurements across the US I think it's a 12-day revisit. We're on the science team there, and one of our tasks is to evaluate it for ag applications. So the soil moisture component will be a central focus. But I think it would be very interesting to correlate, the field variability and soil moisture dynamics with the yield data, but we haven't done that yet.
It sounds pretty exciting, but you can get some idea where the wet parts of the field are and dry parts, and maybe relate that to germination and stuff like that.
Definitely, and I think at this point, I would say the moisture products that we're creating are more suitable for looking at within field variability as opposed to the actual retrieval of volumetric soil moisture content. But as we link with some of the soil moisture sensor work, we'll be able to get a better understanding of that performance.
Thanks, Bill. That's interesting.
Awesome. Thanks, Bill. And by the way, everybody, we have one more remote sensing presentation. And then after that, we have a 15-minute question and answer that we can be hitting up Bill as well as Dean and Jyoti after their presentation. So stay tuned for more question and answer session. Hit it away, Dean and Jyoti.
Well, hi, everyone. This is my first PSA meeting. I'm one of Stephen Mirsky's new postdoc hires working with remote sensing within the network. So Dean, Hively, and I are going to be talking to you today about what we're doing, which is related to what Bill was just talking about, and how we're hoping to integrate within the whole PSA network. So Dean and I are going to be kind of tag teaming between the two of us as we give our talk today. So Brian, will you advance the slide, and Dean, you're up.
So we're starting out with some what-if questions that drive the goals of the remote sensing project. So, for example, what if summer drought is followed by an unseasonably warm winter? You might expect increased performance of cover crops in both quality and quantity due to the drought leading to increased soil nitrogen availability and the warm winter leading to good cover crop growth. Next. If you have a late harvest fall of some row crops followed by wet fall weather, then you might expect poor winter cover crop growth due to delayed planting. Next. And say if you have cover crop endogenous increasing in your watershed by 20%, you might expect a greener landscape overall, increased winter cover crop benefits, and decreased nitrogen leaching. So all of these things are factors that we probably understand as agronomists or as farmers or through observation of plot scale research. Next. But the question is, how do we measure those at a landscape scale or on an ongoing basis? And that's really the driver behind using satellite remote sensing and proximal remote sensing to monitor cover crop growth. You can get a lot of sampling over a lot of area in a rapid method. And then, of course, you need to adjust the scientific challenges behind its interpretation. Back to you, Jyoti. Next slide.
So as everyone has been talking about, really one of the major goals within PSA is to design these decision support tools for farmers and researchers. Next. And these obviously have several components that are led by the very smart people of our team. That includes process-based models, which Dennis and Dave Flesher are working on. Next. It includes the management decisions that the growers are making on their different farms. Next. It includes the soil conditions, which is some of the work that Orly and Resham are working on. Next. And it also is obviously dependent upon what kinds of weather and climatic variation we might experience in a given year or across a multi-temporal sequence. So we're interested in trying to understand these perspectives from historical weather data, but then also what's projected to happen into the future with some of what we expect with climate change. Next. So this is really where myself and Dean are coming into this along with a group of other people where we're trying to take a lot of what we can see from these different blue boxes to then generate these spatial maps of cover crop performance using proximal and remote sensing technologies. Next. So that's kind of where we're going to dig into this a little bit more. Next. So a few different people have mentioned the Normalized Difference Vegetation Index, which I'm sure if you know anything about remote sensing, this is the index that you're familiar with. But just a little background as a reminder on the importance of why this is such a big deal in remote sensing is that it really helps to understand the vegetation greenness across the landscape. And this is partially related to the fact that this, as you look at this graphic here on the bottom left, you'll notice that these different spectral collections, which are of vegetation of cover crops that are planted on different dates, so you can see the different color of lines, are indicating different rye plantings. So looks like November 2nd being the latest date and September 24th being the earliest date. And you'll notice that these different signatures are varying by quite a lot, especially in this near infrared region, which is one of the spectral bands that's used in the NDVI index. And then the red part of the spectrum, which is related to chlorophyll and the absorption of light. So using the red band and the near infrared band, we're able to understand quite a lot about what's going on with plants in terms of their structure and growth development. NDVI is also usually included on lots of different sensors, such as satellites, UAVs, and proximal sensors. Next. But as Bill was just mentioning, and if you've worked with this index, you know that although NDVI can do a really great job up to about 1,500 to 1,800 kilograms per hectare in biomass estimation, once we get above that, we really have this saturation point, which is outlined in that red color there. And there's a few photos here that kind of show you that at lower biomass and medium biomass levels, you're able to do a pretty good job detecting increases in biomass with the NDVI index. But at higher levels, we reach the saturation point. So next. What we're planning on doing and what we're working on currently is trying to solve this problem. So there's lots of other tools and technologies that we're using to try to hash this out a little bit further to see what we can add to our understanding of remote sensing to better estimate these higher levels of biomass within cover crop systems. And this includes additional vegetation indices, as well as proximal remote sensing tools like the forage sensor box and some radar applications like Bill was also mentioning. Dean, you're up next.
So in addition to the quantity of cover crop on a field, we're interested in the quality. And so it is possible to measure the nitrogen content of cover crops through red edge indices. So now in this graph of the cover crop reflectance spectrum, you see the area highlighted as red edge really is the slope between the near infrared and the red absorption. And various research programs, particularly working with wheat for grain production, have related red edge reflectance to nitrogen content. As most of you know, the nitrogen content of a small grain tends to change in different growth stages and also related to soil nitrogen content. And if we can kind of crack the nut of being able to measure the amount of cover crop on the soil and the amount of nitrogen in the cover crop, then it'll certainly give us more tools to measure or model nitrogen decomposition and release to subsequent crops and help assist in farmer recommendations for row crop management. So right now we're in our second year of data collection at BARC using the Sentinel satellite data or the Venus satellite data, both of which do have red edge bands to use, unlike Landsat. And then going out to fields around the BARC station, collecting biomass samples every couple of weeks throughout the year and measuring nitrogen content to develop those calibrations. I will mention that most of our calibrations are oriented towards small grains, and from the remote sensing point of view, we're probably lacking in calibration data for legumes and brassicas and such, and we're trying to address that a little bit also. Next slide.
So I won't spend too much time talking about this since others have talked about the forage sensor box, but this is definitely one of the tools in our toolbox that we're playing with. Just as a quick overview, the forage sensor box, which was designed by Noble, has a few different sensors mounted on it. And you can see there's a photo of kind of the underneath part of the box in that kind of picture with the blue background. And so 3 spectral bands are included within this sensor that allow us to calculate the normalized difference vegetation index and normalized difference red edge index that Dean was just discussing. In addition to those spectral collections, we're also having measurements that allow us to estimate canopy height through an ultrasonic sensor and a LiDAR sensor. We hope to be able to correlate these with and use them for proxies of winter cover crop height, biomass, and nitrogen content. Next. And so ultimately our goals with the box are to link these to field samples. As Dean was saying, we're going out every few weeks to collect new samples this year, and we have a pretty good data set from last year as well that we're working with. And we're going to tie these field samples to satellite imagery, some of the growth models we mentioned in the flow chart at the beginning, and then ultimately link to the decision support tools that get created from some of our work. We hope to also use the box to address some of the NDVI saturation issues and to generally apply across the PSA field site locations as we're starting to really build out where these boxes are driving and hopefully have a broader network to work with outside of BARC in the coming months and years. Next. So I'd like to just walk you briefly through kind of where we're at right now with our remote sensing data flow and how we're integrating all of this. So obviously, you all are probably pretty familiar with going out and clipping plants to get field biomass estimations that allow us to then correlate our remotely sensed data with. So we're interested in both quantity and quality. Next. And we're tying these to the sensor box. Next. And then, as Dean mentioned, we have several multispectral satellites that we're working with that include Sentinel-2 from the European Space Agency, Venus, and Landsat data, and potentially the harmonized Landsat Sentinel data. And these allow us to calculate vegetation indices, and some of these satellites have red edge bands as well. Next. And then finally, we're working in collaboration with one of Dean's postdocs, Dr. Brian Lamb, who's an expert in using radar to do some of the work that Bill Salas was also talking about. We're interested in understanding the moisture conditions across the fields, also estimates of height and roughness that might help us crack that NDVI saturation question. So we're also looking at some of the cross polarization, and we're really just getting going with this work with the help of Brian Lamb. Next, Dean.
So while you mentioned Brian Lamb, Bill Salas, I just want to say that I want to make the introduction between the two of you. I think there's a nice cross collaboration to be had there. So what else can we do? We can look at a time series analysis, looking at the phenology of a crop over time. So this upper right-hand image is a Venus satellite image of cover crop field and its surrounding landscape beginning in March. Next slide. Here's a couple of weeks later, April 10th, you see greening up, a lot more biomass as the spring growth progresses. Next. and then April 24th. So you can see in-field variability, that lower left area being a wet area of the field with decreased growth. And you can see trends over time next. So working with Feng Gao at Hydrology and Remote Sensing Lab, who is kind of a distant collaborator to the PSA network and works closely with me and the cover crop work in Maryland, we can compile the harmonized Landsat Sentinel data stream over the course of the cover crop growing season. You see here on the x-axis is the date range beginning in November. So a green up of the cover crop detected in late November. Not very excellent growth on this particular field, which was a legume cereal cover crop. The peak of growth being in the winter around the turn of the year in January. And then you see a slight depression of NDVI between January 30th and March 31st. This is pretty typical of what we're seeing of cover crops as they go into dormancy and chlorosis for the winter. The NDVI decreases a little bit because of the lack of chlorophyll. And then a very strong spring growth curve resulting in a peak growth around mid to late April. And then we're able to detect termination dates through the interpretation of this growth curve. We estimated eradication to happen sometime between our adjacent satellite images on April 21st and May 16th. So having cloud-free images can be an issue of broadening the kind of the window of your analysis of termination, but we're actually fairly close to the actual herbicide date on this field, which happened on April 30th. So by following this phenological curve, looking at that spring growth peak, looking at the termination and then the growth of the subsequent row crop, we're really able to get at the dynamics of cover crop growth, whereas say the PSA network fields might only have the resources to collect a physical biomass sample in the springtime. Through satellite analysis, we're able to follow this over time and then provide data sets that could potentially be linked to process-based models or other aspects of analysis. Next slide.
So yeah, that last little bit ties in really nicely with what Dean was just saying. So some of our ultimate goals then are to create these maps of winter cover crop performance and supply them to growers for management decisions. And so a part of what we hope to do with that is to potentially identify areas a priori at a point of peak variability amongst the field, which you can see here with these kind of green patch and then the red patch and then the two blue circles. So this is an example of one of our fields. And so if this were an image that we were analyzing, we could then potentially ask growers or assistants to kind of go out and help sample these two areas that could then help us directly tie what we're seeing in the imagery to some physical value that's on the landscape that could help us understand what these are looking like in an actual quantity of interest, such as biomass. We're also interested in trying to identify some of the drivers of performance. So this particular field has a hill, which you might not be too surprised in looking at some of these variations in color across this. So, you know, starting to look at some of the landscape topography and other variables of interest could also help us understand some of these performance metrics, soil moisture, some of the other things that have been discussed throughout this meeting. Next. And so ultimately kind of where we're heading is to try to map some of these sources of variability that could help ultimately identify areas that need precision approaches in the future. Next to you, Dean.
So that's our status of where we're at. The work that we're focused on for last year and this year has primarily been at BARC. And then we really have a mission in the coming year to develop the field scale applications for PSA farms, starting to think about ways that we can create maps and information on those fields that could provide decision support information back to the farmers in the network. So again, kind of the summary, we're looking at mapping winter cover crop emergent states performance metrics and termination dates. We're using Maryland and Delaware enrollment data for Cal-Val. We're also partnered pretty closely with Dagan through the SBIR on this work. Looking at overcoming limitations of NDVI saturation associated with the index saturating above 1,500 kilograms per hectare, using high buoyant satellite radar, and then focused on using red edge for direct measurement of nitrogen content. So those are kind of our science advances we're aiming at this year. And then really just making everything a little more operational and explainable, and integrating the different data sets together in a way that supports the network. Next. In conclusion, thank you very much to the whole PSA team. Jyoti and I have made this presentation, but there are at least 20 people involved with the data collection at BARC and throughout the network, as well as oversight from Chris and Stephen and collaboration with Bill and Steve at Dagan. So thank you very much to all included, and thank you all today.
Well, that was awesome. What a phenomenal presentation and review of both kind of our goals, how we've spread our eggs into some different baskets, how we are achieving those goals, and the synthesis, you know, between the remote sensing efforts, what Kade talked about earlier yesterday on the Forge sensor box, and how we're kind of linking up these efforts. So I hope across the network, folks have really see the connections between some of the different technologies and sensing systems for estimating, you know, performance of covers, and how that's fitting into both kind of our modeling efforts as well as our decision tools and recommendation systems for growers. So I just thought that was one of, you know, a really comprehensive, great synthetic presentation. So thanks, Dean and Jyoti. And we open it up now to a question and answers session for both Jyoti and Dean, as well as Bill Salas, who talked earlier about some of our other remote sensing efforts. So there's a couple of questions that go back deep in, particularly Rob's. So I'm going to try to digest your question, Rob, unless you want to just pose it out.
Yeah, I'll just verbally say it, Stephen. So there's some dialogue going on in the chat box. But Dean, when you commented on the time series analysis, that got me thinking, and I see Bill's responded to this briefly. You know, if we think about a given farmer adopting cover crops, and then if you looked over a several year period, presumably in some cases you'd see adoption radiating out around that farmer. Now, in some cases it could be that's a 5,000 acre farmer that's just putting it on more acres, but in general, you'd hope that some neighbors are adopting cover crops. So when we looked at some census data, we could only break that down by county, and we could identify there were counties that were notably higher than other counties around them in cover crop adoption. So we did just some informal phone calling to those high counties and said, what's driving it? And invariably it was a charismatic individual or a really effective educator, communicator who was making that happen. But I think you guys with your remote sensing tools, at least I'm assuming you could, write some routines to pick out, you know, 5, 10 places in the country where there's really rapid diffusion or adoption around a point where it started several years ago. And if you could bring in the social science team, which Meredith has commented, you know, to understand what's making it happen there so that we can replicate that in other places, that could be a really cool synergy between components of this project potentially.
Yeah, that's a very cool idea. I think I've heard anecdotes from Indiana and such of really hot spot counties happening where the charismatic individuals overlap with, you know, soil types and cropping systems that folks have adopted. And yeah, I think that tool is certainly possible. Bill Salas, what do you think? Do you have the data to analyze that type of thing in the Midwest?
Yes, we do. I mean, we have for the Corn Belt for roughly, I think it's 1.8 million fields. We have annual data from 2005 through to 2020 come in the next month or two. So we could definitely look at some sort of spatial contagion metric that looks at, you know, when a cover crop field first appears in a region, what's the probability of additional fields showing up subsequent years? I think one of the issues that was raised is these are field scale data, so there's privacy issues. So that's why the field scale data aren't on the public websites. But the data is well suited for asking some of these questions and working on some hypotheses on, the early adopters and the impact on landscape level adoption. So we could definitely do that.
Well, and it might even be just as simple as noting that, well, here's a county or township or whatever where that spread seems rapid. And then it could just be a matter of, again, making some phone calls to conservation leaders in that area to pinpoint what some of the dynamics are. And then Meredith or other members of the social science team could follow up with some sort of survey instrument to get a better handle on that. It needs more thinking through, but it seems like there's an opportunity there.
One of the things I'm wondering related to that is whether, we want to be doing our QSOR and our interviews beyond our PSA members as well. And could we be using this for some purposeful sampling across the landscape based on some of this sensing data as well?
I think this could be a really interesting topic to include in one of our weekly meetings that the USDA group is having with Dagan. So perhaps I can talk with Steve Hagan at Dagan about putting together a meeting that could maybe flesh out some more of these ideas between the economists, social scientists, and remote sensing groups.
This is great point. Thank you, Jyoti. It was something I was going to be bringing up later on when I talked about tools and stuff, but I really did want to update our group that there are a number of places to interface with our team for folks who are kind of getting inspired to connect to some committees or groups. Some of these groups are meeting weekly, and so it would be a nice way to connect to this. So we have a weekly meeting with Dagan and the Geosolutions group, and then we have a weekly meeting with the remote sensing team. So I think that first and foremost, what I would like to articulate is that we have our weekly meeting with the PSA remote sensing team is Fridays at noon, right? And so that's a great place for anybody in the PSA network who really is interested, inspired about what we're doing in the remote sensing work. We're meeting weekly. Come join us. It'll take a little while to get up to speed and see where things are going and tap in, but it's a great venue for interfacing with the group. And then we have a monthly modeling team meeting that I think I have announced writ large to the group, but we want to make sure that we're encouraging folks to attend that because that's where some of these more in-depth updates are going to occur. But I also think that, Jyoti, your point is great, that a focused conversation about Optus makes sense to do during the Dagan meeting. And so, these are things we should follow up on.
And I would also say, since I don't know all of you as well as I could, especially as social science folks, maybe anybody who's interested in this idea of Rob's that I think is a good one, maybe just put your name in the chat window and we'll make sure to invite you to the meeting that we're talking about this specific thing.
That would be great. And I also just dropped my contact info. I still am using my university email address, but I will be getting a USDA.gov email address hopefully in the next month. But for now, this is the best email to reach me at if you're interested in connecting with our two teams. I'm kind of liaisoning both. So get in touch with me. I'd love to hear from you. It's really exciting to see these different overlaps between all these different teams. And that's part of why I got into remote sensing personally. So I'm very inspired by some of these comments and ideas.
Can I still ask a question, Stephen?
I think we have plenty of time for Q&A right now.
We
All right.
Yeah.
starting again until 11:30.
Okay, just a question for Bill again. I guess, Bill, I've been using the Optus data for some of my work, and some of the questions that came up from reviewers in utilizing the Optus data for doing statistical analysis, of course, the accuracy of the Optus data. You mentioned in your presentation a 90% accuracy, and could you talk a little bit more of how that was sort of calculated, and also sort of if you have any sort of paper that we could cite to support the accuracy of the Optus sort of county level data, that would be great.
Yeah, I'll send you a copy of a paper that was published about a month and a half ago that reports the accuracy results. So on the cover crop analysis, what we did is we hired crop consultants to go out across 30 different regions in the Corn Belt. And we developed a mobile app and field data collection protocol specifically designed for validating remote sensing products. So we have about 1,000 data points that we use for the accuracy assessment of the Optis work. So that was the basis of that 90% number. We also have estimates of residue fraction and crosswalk it with tillage systems, but that's a little more difficult to quantify because you're talking about categorical variables for reference, but the remote sensing is giving you a single residue fraction. So for example, if you have 0 to 15% residue class and 15 to 30, and they say it's a 0 to 15 class, but your remote sensing estimate is 20%, you've actually done really well with the remote sensing to be that close. So we have another statistic that we call a weighted kappa that takes into account the how bad the error would be by having the wrong tillage class. And that's discussed in that paper as well.
Have you looked at sort of just aggregate comparisons with the Census of Agriculture data?
Yes, we have. And there's strong correlation, but there's a fair amount of scatter. And I think it's driven on the cover crop side by two main drivers. One is poor stand establishment. So the census data said, yes, I planted a cover crop, but how well did it establish? So that's an error of commission, meaning we said there was cover cropping, or we said there wasn't, and they said there was cover cropping. The other is volunteer and weeds. Again, in the census, there's reporting planting of cover crops as opposed to weed pressures. And we do know in some regions that we have significant co-founding effects from weeds versus intentional cover cropping. And so we're working on how to try to separate that out. That's an ongoing research question.
Okay, thank you. And last question on your comment about expanding the Optis to the Great Plains and so forth. Will that be retroactive, meaning you'll still have the 2005 to 2020 data on those additional states, or will it just be new data on those Great Plains states?
All expanded areas will have at least 7 years of historic data. Some sites didn't go all the way back to 2005, but we recognize that setting the baseline is important to understand interannual variability associated with different cropping systems. So we have at least, I think all sites will go back to at least 2010, but I have to double check.
All right, thank you, Bill. That's all I have.
Sure.
And I agree with Bill that, Jyoti and I perhaps presented a somewhat rosy case here of what we have been able to achieve with the remote sensing, but it can get messy with weeds in particular and with cover crops that perform poorly overlapping with fallow fields and with the time series in the springtime to separate cover crops from small grains and all. So, this is an evolving science, but I love being able to work with all of you to bring it out into practical applications as much as possible.
And you talk about, Dean, also the landscape sometimes, like the North. That's why it's hard to do this remote sensing in the Northeast. Is that still true on the landscape and sort of the topography of that stuff?
Yeah, I have a slide for a different presentation that shows, a 2-mile square block in Iowa versus Pennsylvania. And in Iowa, you have all of your quarter section fields that are fairly amenable to MODIS pixels at a large scale, for example. And in Pennsylvania, you have narrow strip crops on the hills that are in some cases only 40 meters across this twisty strip. So I think that the good thing we've seen in recent years is that satellite imagery is advancing. Even bringing Sentinel online in combination with Landsat has made a big difference, and it's only going to get better. So I do think that pushing the analysis into complexity and small scale is important because, as you all know, complicated crop rotations and crop diversity and spatial diversity in the landscape is sustainable, but it's also hard to analyze in comparison to a big uniform corner soybean field. So as time goes along, I think we need to really recognize that we all have a slight bias towards analyzing what we see most easily. And it's really in the complexity that you have the sustainable system. So it's tricky.
But I think you make a really good point here, Dean. I mean, I like this linkage. I mean, a lot of these questions coming up in the chat box and part of this conversation is all around, presence or absence of adoption of cover crops and drivers and linking that up to some of these landscape features or other socioeconomic dynamics. And I think all of that is ripe and moving along, and there's a lot of great opportunity there. But I think part of also what PSA is trying to offer, which you and Bill and certainly others have been involved with historically anyway, is also really improving that in-field spatial variance estimates and performance criteria, so that kind of fits into this narrative where it's not just presence or absence of cover cropping, but the degree and magnitude of efficacy and performance is kind of part of that continuum for our team.
Stephen, I just put a link to the article that I referenced in the chat box.
Oh, great, thanks.
Thanks.
I think we still have a fair bit of time for questions. Where are we, Sarah? Let's see, we have, we have a break that already started.
Yeah,
Yeah.
so we're going to do the break. So feel free to go and, get your fresh coffee or whatever. But we can certainly keep rolling with the Q&A during the break.
Yeah, if there's more questions for the remote sensing team, let's keep going. I know there's been some questions in the chat box. If folks want to vocalize those, let's do it. Or if someone needs to go take a break from the remote sensing team, then go ahead too.
And for those of you curious about breaks or questions, we're going to start back at 11:30. So we still have a little bit of time for that. Let's see, what are we starting at 11:30? Oh, data analysis at 11:30.
Well, if folks are still around who want to talk about Rob Meyer's idea of using the remote sensing to look at the spread, I think it's possible to use multi-year remote sensing analysis of the type that Bill Salas is producing to kind of do a cluster analysis and maybe find points of spread. But then how do you avoid biasing that or overlaying that with actual knowledge of innovative farms on the landscape? Do the social scientists have any advice about that? How you almost need to collect an independent data set about cover crop innovators and then see if the two match up. Does that make sense?
Yeah, this is Rod, Dean. That's what I was thinking. But initially, you could use the data for some sort of spatial. And I saw in the chat that Linda over in Purdue has done some work on this. But do some sort of spatial Moran's eye, for example, to just find the clusters, the spatial clusters, where high adoption counties are neighbors to high adoption counties, or where there's no correlation at all. And then from there, you need to match it with some sort of data, as you've said, if there's sort of like some measure of extent of extension education or something like that, and see if there's correlation. So those kinds of things I think could be done. But again, the question is whether there's data to be put on the right-hand side of the equation that we could collect.
That's right. For example, up in Pennsylvania, their cover crop subsidy program goes county by county rather than statewide. And so there are some counties that actively promote cover crops and others that don't. So that might be a case. Or, yeah, you could think of several factors influencing it. I think biophysical variables are important too. There are areas that are just more amenable to cover crops because the row crops get harvested earlier, or because there's more rye silage or more silage harvest with rye following it, or, you know, various other aspects.
Or even
But
weather, right? Sort of climate in the area or the region.
absolutely, absolutely. And that's one thing that we're seeing in our multi-year analysis using Landsat, is that the warmth of the winter is the primary driver of how green the landscape is. So we have to normalize that somehow. So it's exciting that we're getting to the point where, you know, the data sets like Optus is producing are even available to consider this type of analysis. But maybe something
Yeah,
to
I
put
think-
on the drawing board for 2021.
Just to weigh in on that too, I would agree. I mean, I think that we would want to include climate variables and biophysical variables plus the social and economic dimensions to explore some of those potential adoptions over different county levels. And this team would obviously have the capacity to do all of that.
Sounds like a grant application, Stephen.
I have one comment on that also. For each of those field segments, we do have soil information because we actually extracted from G-Surgo to do the DNC modeling. So we could begin to, even if we do it at the aggregate scale, at the county scale, but have a distribution, right, of the soils that are where the cover cropping is occurring, if we want to, you know, look at the edaphic controls as well.
And I'm obviously biased to this whole conversation around the qualitative stuff, but I do think that this is a place for us to then start to, you know, match up our ground truth, what we think that we understand about the adoption dynamics with people's experiences, and then we can extrapolate and move to survey. So I'm a big believer that like good qualitative underlies good survey data. And since we plan to be trying to sample more broadly beyond the PSA network anyway for our Q-sort and interviews, it seems like it would be a good opportunity to do some of that sampling, drawing on the multi-year satellite imagery. So I definitely would like to chat with you about how we could think about that even for a small subset of our samples. So, you know, I'm thinking something like 10 to 12 interviews that could help us maybe make sense of that. And maybe we target it in one specific region so that we get a good understanding of the dynamics in one place instead of spreading ourselves too thin and not understanding anything at all.
I like it. So Stephen Mirsky, how do you think we should best organize this kind of new team that's forming here?
You know me all too well, Dean. I'm sitting here spinning in my head about what I'm going to say to everybody and how I'm going to like put an action item on this. So I'm sitting here in my head. This is what I'm thinking to myself. One is that it's clearly both the folks who are motivated and excited about the social science team and engaged with that group. I mean, those folks are just lighting up the chat box right now, as well as those, you know, kind of the scientists engaged in remote sensing. So it does feel like we have two groups here that are really motivated around these questions. And so I think what we need is kind of a group whiteboarding session to articulate some of our, you know, kind of objectives, interests, and targets. And then in that session, we're both identifying those, but then also what are key deliverables that we see we're capable of already hitting within our PSA momentum and hired personnel and you know, at our current staffing level, so to speak. You know, what are we thinking we can squeeze in, and versus where do we need some additional scholarship, and where we need additional scholarship, we are going to be hitting, you know, the NEFA Foundation programs is going to be turning the corner in the spring and the summer. And a team like this would be ripe to spend the winter formulating out our questions and interests and then targeting a couple of those programs if we do need some extra scholarship, you know, in the form of graduate students and postdocs and such. So I would propose that we have like a session that probably isn't necessarily tied to our existing remote sensing meetings or our existing social science team meeting, because this feels like it's a 2-hour meeting just to have this first kickoff session. and then focus kind of our, how we want to direct things going forward. So I'd like to just propose this. If you're interested in being part of this first whiteboarding session, please email Jyoti, who put her email up in this chat box once, but we'll do it again. And so just email her directly and she'll keep a running tab of those folks. And then we'll try to set up a meeting. And I suspect it may be difficult to pull off this meeting before the new year, but we'll try to either do it before the new year or early in January. Does that seem like a good next step?
That makes sense.
Sounds great.
Okay.
I like it.
Okay, good. All right, we're getting positive. If there's anybody who thinks we should be, any other approach, then let us know or put it in the chat box. But if that seems like folks think that's a good next step. So Jyoti, did you put your email back in there just to fresh it up at the top of the chat box? And don't get confused, because we are really close to having a USDA.gov ending to Jyoti's email. She's close to being in the USDA system right now. She's kind of hired in a different capacity. So if you see her email say Idaho, it's because she's still using that old email address. We may have lost her because she's not putting it in there. So
I think she's on break. Why don't you post it?
Yeah, I'll post it. Okay, she doesn't even know what I'm signing her up for. So but that sounds about right. Okay, folks, I'm putting it into the chat box, but just be aware that again, in probably a month, I imagine a month, that it'll be a USDA email. So she'll have to let folks, update folks that revised email in the near future. So if you see Idaho and you're confused, just be aware of that. But cool, this was awesome to see all the energy and excitement around this project. We're super excited about where it's going and all these different collaborations. And you guys have introduced a lot of new concepts that we were even thinking about. So with that, we are going to spin over to our fearless leader, Chris Reaver Gordon.